You're worthless, although I still love you. I'm the best thing that happened to you. You give me blues on purpose.
Called a contour map. And you guys might have heard of this before or seen it. Alright, so what is a contour map? This is basically a plot, or graph, whatever you want to call it. So a plot in the xy plane. So again, this only exists in the xy plane. Okay? And this shows level curves. So the things that we just learned, level curves, and that's when a certain plane at a certain height, like z equals some constant, right? When that plane intersects our surface and it creates an intersection. So level curve is the projection of that intersection onto the xy plane. We just drop it straight down, okay? So that shows level curves. So f of x, y is equal to c. That's what represents level curves, right? For, and this is the important part, for equally spaced values of c. Okay, of c. So what that means is that let's say we have some graph. Okay, so let's say we have some graph that looks like, again, I'll draw something that looks like mountains because that's always good for like contour maps, right? I don't know if you guys have heard of like topography or something like that it's called. Anyways, so it just shows you like the heights and of like mountain ranges and landscapes and things like that. So anyway, so let's say we have two mountains like that, okay? And here's our surface, okay? And so what we would do is basically, for a contour map, what we do is set z equal to varying constants, okay? So here's one like C1, okay? And here's C2, and here's C3. And these ones, the distance between, or the height difference between C1 and C2, so C2 minus C1 should equal the difference, the height difference between C3 and C2, because the intervals, we want them to be the same, okay? That's what it said, equally spaced intervals. So anyways, we would have a bunch of different planes cutting through, and we would get something like, here's at C1, we would get something like that, okay? And then C2, we would get something like this, okay? And then C3 would give us a little, like, tinier circles, right? So something like that, okay? And if we were to drop all of these down, project them down, we would get something that looks like, okay, that was a really bad projection line. Okay, something like that, okay? And I'm just doing this kind of quickly. This here, the most important part is that you guys get the concept of it, not necessarily, like, I know not all of us are aspiring to be artists in the future, but it's always good to know how to draw graphs, right? So anyways, so it looks something like that, right? The circles get progressively smaller as we increase our height, our c value, okay? So anyways, these things that I wrote here, the height difference between each of our constants that we're setting our constant heights, right? So z equals c whatever, etc., etc. This is called, these are each equal to m. That's what we call our, not our slope, but this is the interval between the c values, the different c values, different c values, or the height values, c values in the contour interval. Okay? So anyways, so this is the interval, we call it the contour interval, okay? Specifically or formally, that's what the name is. Anyway, so let's see, that was just a quick definition there on the side, okay? Let's look at the xy plane. What do we actually see? So if we look at our, here's our, let's say this is x actually, and then y, so we don't have to change it too much. It looks something like that, and then we had a bigger one over here, okay? And then we have a smaller circle in here, and a smaller circle in there, and then, and that's not even a circle, that's an oval. So anyway, so these two here, this curve and this curve, those are both obtained at height C1. This curve and this one, those are both C2. And finally, the innermost on both of them, that was from C3. So those heights would be labeled. Anyways, so again, this isn't like super important that you definitely know how to, that you definitely need to know how to draw a contour map. This is just more conceptual and understanding what's going on. So anyways, one other important distinction or something to point out is that in R3, so in R3, which is space, right, 3 dimensions, we have level curves, okay? Level curves. So this would be like the f of xy. So this would be our f of xy equaling c. But in 4 dimensions, so in R4, that means that we have level surfaces. Level surfaces. And surfaces exist in 3 dimensions, right? So basically anything, if you want to level or set anything equal to a constant, it goes down by 1 dimension. So for example, like in R3, we started in R3, and then we set something equal to a constant, so we basically like eliminated 1 variable, right? And so now we're left with a level curve, which is just a 2-dimensional thing, okay? So, and then similarly, if we start in R4, which is 4 dimensions, and if we set one of those dimensions equal to a constant, so it's not a variable anymore, then we're left with a level surface, which exists in 3 dimensions, and those 3 other variables can still move around, okay? Alright, now for one last concept. So when we have surfaces that look something like, okay, let's draw a graph here and see what it looks like. So let's say we have some kind of graph that goes up to like a hill kind of thing at one point, right? So this is our surface, and what we can do is actually calculate the average rate of change for something. So average rate of change, usually, or not usually, but sometimes this is abbreviated as AROC, right? Average rate of change. That's pretty useful. So sometimes we want to calculate this, so we'll say that the average rate of change is equal to, from like P to Q, okay? So let's say P is down here, kind of at the bottom of the hill, and Q is up here, all right? So what is our average rate of change? That's basically going to be, we're going to draw like a triangle kind of thing, right? So this is going to be like the whole rise over run thing. So this is the change in altitude, this side here, altitude. So change in height, right? Altitude means height, okay? And then our run down here, that's going to be the change in the horizontal direction, horizontal, okay? So that's going to be our average rate of change. That's going to be AROC, average rate of change, is equal to the rise over the run. So change in altitude divided by the change in the horizontal direction, horizontal, which is parallel to the XY plane, right? So that's basically it. This is kind of like, if you notice, so this is like a rise over a run, right? So that's kind of like a slope in a way. So this is like a slope, right? Calculating that average rate of change. Okay, so that does it for this video. I hope that helped on functions of 2 or more variables, and I'll talk to you in the practice problems video if you watch.